So today I will show you on how to compose square wave, triangle wave, sawtooth wave from sine wave by using scilab, and as well on how to use the wavread function. Okay, first of all, we want to compose the square wave first. So in order to plot the square wave, we need to plot the sine wave first. So this is the coding to plot sine wave. Okay, for y, I'm using the formula of sine wave, and I'm using this formula. This formula with the frequency is equal to 1 kilohertz. The A is equal to 1 kilohertz. So I'm set the pi 3.14. Save and we execute. So this is the output, which is the sine wave. And then after the sine wave is completed, then we plot the square wave. For square wave, I'm using the same x and the same pi, and the formula of square wave that I'm using is I'm using this formula. Okay, for square wave, in this formula we have k. Our first k is equal to 1. The more k you use, the better your square wave will be. Okay, I will show you what is meant by when using more k, your square wave will be much better. Okay, let me reduce the k first. Okay, let's say I'm using k is equal to 6. When I'm execute, I will have this. The line on the square wave is not perfectly straight line on this side and as well on this side. Let me execute once again so you can see it. So when I'm using k is equal to 30 and I'm execute again, the line on this area of square wave, it will be much more straight line, because at this area, the more sine wave you compose, the more the line will be straight. So if you using higher k, so your square wave will be much better. And let me execute as well the sine wave. So the result is this. So the output when I'm execute the sine wave and the square wave. Next, move to triangle wave. For this triangle wave, I'm also use the same x and the same value of pi, and for this triangle wave I'm using this formula. I'm using this formula actually. The formula that I'm using for square wave is this. This is the formula that I'm using. So here it use n. So okay, for this triangle, the n is odd number. So meaning that you only can use 1, 3, 5, 9, 11, 15, which is the all of the odd number. You cannot use the even number. So for this triangle, I'm using the n is equal to 25, means 1 until 25. Odd number from 1 until 25 I'm using. So just like the square wave, the higher n you use, the better your triangle wave will be. So let me show if I'm using the less n. Let's say I'm using only 5. N is equal to 5. I only use 1, 3, 5, 6, 5, 7, 9. And my n is equal to 9. So when I execute, so when I execute, this is the triangle wave. Okay, then I compose the sine wave as well. I execute the sine wave as well. So you can see why we need to use more n. Okay, can you see the gap between the triangle wave and the sine wave? There is a gap of all of the wave. Okay, then let me add more n. So right now I'm using n is equal to 25. So when I execute again, it will be this peak of the triangle wave is sharper than the previous one. So when I execute the sine wave, the gap should be less. Can you see this? The gap between the sine wave and the square wave is reduced now. So the more n you use, the better your triangle wave will be. And now for sawtooth wave, so for sawtooth wave, I'm using this formula. I'm using this formula for sawtooth wave. This is the reverse of sawtooth wave. So the K I'm using as well is a little bit higher. K is equal to 40 to get a good line of a sawtooth wave. So when I execute, okay, can you see the line? It's not perfectly straight line, but if you want more straight or perfectly straight line for this area, you can add more K one K value. In this case, I'm using K equal to 40. This is my K 40. So let me show if I'm using less K. Let's say I'm using only 20. Okay, let me show you only 20. 20 K is equal to 20. When I'm execute, can you see the line is not smooth like the previous one? So that's why you need to use more K. So I'm using K equal to 40. Execute and See, the line is much better now. So when I execute sine wave, as well as the square wave and triangle wave, so the output all of the triangle wave, square wave, sawtooth wave, and sine wave in one output is like this. Okay, moving on to the wavread function. For wavread function, it is a function that loads the sound file, the sound file of wave file. So first I have record audio sound, which audio sound of my name is Nabila, and then I already convert the file, convert the audio file into wave file, and I put the audio wave file in here. So for wavread function, okay, to use the wavread function, I using this website as a reference. This scilab website, it has tutorial on how to use the wavread file. So this is the syntax. So I'm using this example as my reference. Here it has two channels, first and second channel, but I'm only using the first channel. Only one channel I'm using. So, okay. The wavread function here is to call or to load the sound file, the wave file. And this line code is to return the sample rate in hertz and the number of bits per sample. And subplot and plot 2D is to plot the output. So when I execute this audio, it will show like this. It will show the sample rate in hertz and the bits per sample. It has four, partition of the number bit per sample because I record my name is Nabila. Okay, that's it. Thank you.